utilizing the code node to investigate light behavior. And light can travel in a straight line until it interacts with another object. Then the light can either reflect, which means to bounce off of, or refract, or to go through, or even be absorbed by that object. Let's take a look at this video. Refraction is the bending of light waves caused by a change in their speed as they pass from one medium to another. The water also acts as a magnifying glass, which bends light towards the center. The image looks reversed because the light that was on the right is now on the left. This refraction causes the horizontal lines to appear as if they've been reversed. As a form of electromagnetic radiation, light travels in waves, with some of its colors having longer wavelengths than others. White light is not a single color, but a mixture of many colors. The color of light is determined by the light's frequency, and the amplitude of the light's wave determines the intensity or brightness of the light. The visible spectrum, which you see here, is the portion of the electromagnetic spectrum that is visible to the human eye. An object has the colors of wavelengths it reflects. A material that reflects all wavelengths of visible light appears white. If the color of the surface is anything other than white, it absorbs light of some of the wavelengths. So for example, a surface that appears red appears that way because it's absorbing all the other colors other than red. So we can investigate how colors reflect light, and today we're going to do that with this great setup to do color reflectivity. We are going to be using the code node and focusing on the light sensor on this code node. And just so you know, it measures light and brightness, so from a percentage from 0 to 100%. So you can take a look and see all of the different colors that I have here. We have yellow, blue, aluminum foil, orange, the white that's preset here, green, and black. So out of these, can you guess which one is going to have the greatest reflectivity? Which one is going to reflect the most light? Which one is going to absorb the most light? All right, so think on that for a second. All right, let's give it a try. I'm going to open up SparkView. All right, and from SparkView, again, my focus is going to be using the light sensor, so I chose brightness as our unit of measure. And I've just created a line graph of brightness over time. I'm going to turn on our LED flashlight. And you could do this at home too, just have somebody hold each of these while you perform it. But since it's just me, it was easier for me to create this setup. All right, so let's get started. I'm going to click Start. So it's saying about 7.8%. Let's move to blue. That decreased quite a bit. So that means the white was more reflective of light than the blue. Let's try orange. Green. I'm curious what the yellow is going to do. That one reflects even more light than the white did. Let's try the black. Looking at that data, if you said you felt the black was going to absorb the most light, you might have been dead on there. All right, and the foil. Big jump there as well. So I went ahead and I actually created this data previously and labeled it for you so you could refer to it. All right, so this is essentially what we just did. I went ahead and labeled each of the colors so I could refer to it later. And I can see that the yellow was pretty high up there, but the foil was the most reflective. And you might want to do a little research on why that occurred, kind of looking about how light behavior is and how it might be dispersed. And then, of course, the black absorbed the most light. Therefore, it had the least brightness reflected off of it. All right, so that's just a fun investigation that you can do with the code node using the light sensor looking at color reflectivity. All right, so now that we've talked about light behavior, and we know how the code node measures light in percentage from 0 to 100%, I wonder, could we recreate an automatic nightlight? I'm sure you've seen these before. My grandparents had them. They always kept them in the bathroom for me when I was visiting so I could find it in the dark of night. And essentially the way an automatic nightlight works is when the lights turn off, the sensor's covered and the light comes on. And then, of course, when the lights come on, the nightlight turns itself off. So let's give it a whirl. All right, so we're going to build this program together. It's a pretty simple one. So I've gone back into SparkView and I'm going to choose sensor data. And I want to make sure that my code node is connected. I'm seeing green. That's letting me know that it is paired. And the only sensor I'm going to utilize for this is brightness, which again is the light sensor. So I'm going to disable the other sensors and choose the line graph. And then I'm going to draw your attention to the live data bar that's at the bottom left-hand side of the screen. You can see right now it's saying that the brightness is at about 6.5%. If I cover that light sensor, it drops down. It's not going to 0 because some light can get into part of the code node, and there's a lot of bright lights in the studio here, but you get the gist. So you cover the sensor, the percentage goes down. That's important in our code. You're going to click on the puzzle piece, and I'm going to start with a loop. This is our pretty standard loop saying as long as what I put in there is occurring, just keep running through that program. Pull in a logic block and a comparative block. And the hardware we're using, again, is the brightness. And I'm going to pull in a math block here. So let's say as soon as the brightness is less than, let's do 3%. Then I want the RGB LED light to come on. You'll see that's on the exact opposite side of the light sensor. If it is not less than 3% brightness, I want the light to be off. So I'm going to put 0 in for all of those spots. Let me expand the program a bit so you can see it. So not too bad. So let's look at it again. If the brightness is less than 3%, then the RGB LED light will come on. If not, it will go off. All right, so now that we have our program complete, let's see how it works. I'm going to press start. And as soon as I cover that light sensor, there we go. The RGB LED light comes on. That's letting me know that our program was a success and you have yourself an automatic nightlight. You'd find in the dark that that LED light is pretty bright. All right, so your automatic nightlight was a success. So let's talk a little bit more about this RGB LED because it's actually pretty interesting. So when a combination of only red, blue, and green of equal brightness is overlapped on a screen, it appears white. RGB color is a color additive model in which red, blue, and green light are added together in various ways to reproduce a large range of colors. Red, green, and blue are primary additive colors because the human eye has photoreceptors that take in these colors. In fact, almost any color could be made by overlapping light of these 3 colors and adjusting the brightness of each color. So let's try a little color mixing. We're going to talk about complementary colors here in a second, but when we're talking about color mixing, I want to point out the model. We're actually now going to utilize the same program we had for the nightlight, but we're just going to adjust the output, which is the RGB LED, to see if we can create these other colors. So looking at this model, when you combine red and blue, you get magenta. When you combine red and green, you get yellow, and green and blue, you get cyan. We are now going to try some color mixing with our RGB LED to see if we can create those magentas, those yellows, and those cyans. All right, so I've gone back to my original program that I've already created, but you'll notice I actually made the brightness go even lower. Our original program was 3%. This one I put at 1%. So let's see what happens when we only color mix with red and green and cancel out the blue. We get yellow. Okay, let's stop. Let's see what we get when we do red and blue. There's that really cool magenta color. And last, what do we get when we do green and blue? That awesome cyan color. So that's color mixing in a nutshell with the RGB LED. And you can do more investigations. Remember, by adjusting the brightness, you're going to be able to change the color of this LED. So you could work with oranges, tons of different colors. You just have to adjust the brightness on that particular piece of hardware on the output for the RGB LED. All right, so just a reminder, the color mixing you just did, we're working with complementary colors with the RGB color model. And essentially what that means, again, when you're talking about screens, computing devices, is that complementary colors are pairs of colors that when combined, they cancel each other out. They produce a grayscale, and in this case, it's white. So when we put red with cyan, that's going to actually give you white. So if you're ever looking for the complementary color, when you're looking at this RGB model, just look for the color that's directly across. So the complementary color to green is magenta. The complementary color to blue is the yellow. With that in mind, we're going to leave you with a little teaser. You might have heard of reverse images. So I have this picture of the American flag up there, and think about what we just talked about with complementary colors. You're going to model something called retinal fatigue here in a second. I'm not going to give you all the answers on it because I want to leave you with something kind of fun to go back and do some research on to find out how this works. So I want you to take a good look, stare at the American flag in the middle of the screen. So stare at the middle of that flag for about 10 seconds. Did you see it? Did you catch it? Let's try it again. You stare at it long enough, you're gonna see the complementary colors, which is the opposite color from that color wheel. Pretty cool. I caught it big time that time. So feel free to refer back to that video. It's pretty cool. Again, we're not going to tell you all about it because we want you to do a little bit of research on your own. Thanks for hanging out with us with the Code Node and learning about light behavior.